Welcome back. I looked over, these are probably gonna do the next 3 examples, and I'll save the other ones for class or something. They're not like massively important, all the different kinds. They all are used the same way, but I kind of wanted to show you guys a couple different ones. So anyway, so let's do this. We're going to, like we did before, we're gonna build the LCD for all these things, and I'm gonna multiply everything by that LCD. So this 2x minus 2 is really 2 times x minus 1. I factored it here. This is important because when I build the LCD, I need to know what all the factors are. That's what we did in the previous 3 examples. So the denominator of this one is 2x minus 2, which is 2 times x minus 1. The denominator of this fraction cannot be factored. It is just x plus 1. The denominator of this third fraction cannot be factored. It is just x minus 1. And the denominator of the last one is x squared minus 1, which hopefully you recognize as the difference of squares. It is this. So these are my 4 denominators, and I've written them here factored. Now I'm going to build the least common denominator. So it doesn't really matter which one you start with. Might as well start with the biggest one because you're going to need all those factors at some point anyway. So I'll start with x minus 1 times x plus 1. So I'm good. I got that one. I got all the factors of this in my LCD. X minus 1 is already in there, so I can cross it off. X plus 1 is already in there, so I can cross it off. 2 is not in here, so I need to add it. X minus 1 is already in there, so I don't have to worry about it. So boom, this is my LCD. This is where things might get a little funky. I don't want you guys to get freaked out or anything, but I'm not gonna write every, like I said before, I wasn't gonna write every step every time. And I'm standing by that. So here's what I'm going to do. I'm going to write it like this. I'm just going to write it on the top. I'm going to write it on the bottom. And then I'm going to just say equals. I'm not going to write out all that like this times this and this times this. I'm just going to look. I know that the bottom, I think I should rewrite this thing because I factored the bottoms. It's easier to see if you rewrite it. Oh boy, that's not what I wanted to do. So I'm delete this one thing. That would be smarter. So this first thing was really 3 over 2x minus 1. It's going to make more sense when we cancel things out if you factor these things now. 1 over x minus 1 plus x over, this has the 2 factors like that. So now I'm multiplying the top and bottoms by this. This is the LCD now, right here. So we think of it like multiplying the top by this LCD and the bottom by this LCD. So now this is why if you factor these, you can see what crosses off a lot easier. So on this first multiplication, this LCD times this fraction, I can see that the 2 in the LCD and the 2 on the bottom cancel out. The x minus 1 here and the x minus 1 cancel out. The x plus 1 doesn't cancel out, so I have to multiply it by 3. So I get 3 times x plus 1 for this first multiplication. For the second one, I put a minus sign because there's a minus sign here. The 2 doesn't cancel out because there's no 2 on the bottom here. The x minus 1 doesn't cancel out because there's no x minus 1 down here. The x plus 1 does cancel out with this. So I'm left with 2 times x minus 1 times 1. Do the same thing down here. Multiply this thing times this fraction, and then this thing times that fraction. So the 2 stays because there's a 2 here, but no 2 on the bottom. The x minus 1 cancels out with that x minus 1, and the x plus 1 has to stay because there's no x plus 1 down here. So I have 2 and x plus 1 times 1, which is 2x plus 1. A plus, so I put a plus. And then I can see the x minus 1 and x plus 1 are going to cancel out, and I'll be left with 2 times x, which is just 2x. So you can see now I started with this ridiculous complex fraction, and now I have a normal fraction with x's and stuff in it. You know, it's probably a good idea to multiply these things out and make sure that nothing else cancels. So the top here is 3x plus 3 minus, this is 2x minus 2. So minus 2x plus 2. And 2x plus 2 plus 2x. This is x plus 5 on top. And 4x plus 2 on the bottom. Nothing here simplifies. I mean, we could factor this into 2 times x plus 1, but 2 times 2x plus 1, but it wouldn't change anything. So again, the point here is to simplify the complex fractions, but also to like be mindful of the stuff we did before and remembering how to factor things. That's also important. So this picking the correct strategy note is like whether you wanted to pick number 1 or number 2. I don't know why anybody would ever not pick the second one for this one, but so for this one, you can see this, the denominator, for all these ones that have no denominators, the denominators are 1. Okay. Okay. So really the LCD of the top here is A, because A is the only denominator. And the LCD on the bottom is also A, because A is the only denominator. So I'm going to multiply the top and bottom by A. And I get A times A for the first term is A squared. A times 3 for the second term is 3A. And A times 2 over A, the A's cancel out, and I'm left with just plus 2. In a very similar way, in the bottom, I do A times A times 6, A times 5 over A. I get A squared plus 6A plus 5. And hopefully you're like, I bet I can factor this. And the answer is, you sure can. A plus 2 and A plus 1. And then A plus 5 and A plus 1. And those can cross off, and I'm left with A plus 2 over A plus 5. So the strategy means like whether you were going to add these together and then divide like I did the first time, or multiply them all by the LCD. This is when we're multiplying by the LCD is like the only way to do this. Doing it any other way is silly. So one more example, and then we'll be done. We'll talk about this reciprocal thing in class maybe. This one looks a little different, but it's because of the negative exponents. We talked about this in the last unit, so you should know that this equals x squared over y. That y to the minus 1 goes to the bottom. Minus 5 over x times z. And so now this maybe doesn't look like a complex fraction initially, but now you can see that it really is. So you have to simplify it. I'm going to tell you right now, without a lot of fanfare, that the LCD of these two fractions is xy. There's no common factors because this one's just x and this one's just y. And the bottom doesn't have any fractions, so I don't have to worry about that. It's like x is e over 1. So the LCD here is going to be xy. So I'm just going to multiply the top and bottom. Yeah, I do the top and bottom by xy. And when I do xy times the first guy here, the y's cross off, and I'm left with x squared times x, which is x cubed. Xy times this one, I cross off the x's and I get negative 5y. On the bottom, there's nothing to cancel, so I get x times x is x squared, and yz. That looks like garbage. I'm gonna write that z again. So sometimes these things don't look like complex fractions, but they really are. So you got to kind of keep an eye on that. That one was really fast. Yeah, this one's a nightmare. I'll do this one because it has many fun factoring pieces to it. Put that in the wrong spot, I feel like. Oh yeah, for sure. So I'll put it right here. It'll be on y'all's, it'll be the next one, I promise. So I can never get it there. So On yours, it'll be right after that one. Maybe, okay. So we just did this one, now we're gonna do this one. This one looks like it's terrible, but if you factor everything first, then it becomes much easier. So you get y. I'm not gonna factor all the denominators here. None of the numerators can be factored. Y squared minus 1 is y minus 1 times y plus 1. The denominator of this one is y plus 1 and y plus 4. This one is 3y over y minus 1 times y plus 1. And this one is y over y minus 3 and y minus 1. I said that in the right, in different order than I wrote it, but it's the same thing. So there's like a bunch. Now we see that the denominator of each one of these fractions has 2 factors. So you can still build the LCD the same way. I'm going to build it. I'm not going to have enough room to write it because it's going to be pretty long, but I'm going to write it up here. So to start with, I take this denominator, which is y minus 1 times y plus 1. Remember, this is the LCD I'm building up here. That was crazy. LCD. So I take this first denominator, and I need both of those factors. Now I look at the second denominator. I need a y plus 1, which I already have, and a y plus 4, which I do not have. And for this one, I need a y minus 1, which I have, and a y plus 1, which I have. That's not surprising because these two denominators are the same. And for this fourth one, I need a y minus 1, which I've got, and a y minus 3, which I don't have. So my LCD is this big, stupid, long thing. And if I multiply, that's unfortunate. If I multiply the top and bottom by this big denominator, then a bunch of things cancel out in the tops and the bottoms. Like a ton of things cancel out. Like 2 factors cancel out every single time. So I was thinking I would like write this here and then maybe do one of them and then leave the rest for you guys to do as like kind of like an assignment almost like a homework assignment. You all have heard of those. So if I was going to multiply this whole big thing, all 4 terms by this first fraction, like I'm going to do all of this times this fraction. What it's going to leave me is this. The y minus 1 and the y minus 1 are going to cancel out. I'm going to actually cross them off, so I'm going to do one of these. This is going to cancel off with that. This is going to cancel out with that. But I'm left with a y times these 2 things. So I get y times y plus 4 times y minus 3. And that's what this whole term, this whole big first term, when you multiply it by this denominator, by this LCD, the denominator crosses off, which is the whole point of doing this, because I want to get rid of these big, stupid, complex fractions. So I did that, and then there's going to be 3 more of these to do, right? There's going to be minus, and then you're going to do the same thing, this big denominator times the second one of these fractions, like this. And then you're going to cross off different things, and you're going to have 3y times whatever's left, and the same thing on the bottom. And then you can probably multiply all that stuff together and make some other big, horrendous, maybe that thing can be factored at the end. So give that a shot on your own, and I'm happy to talk about it in class. Bye.